వినోద్ సార్ ఇంకా ఆగండి, మన క్లాస్ అయిపోలే. వినోద్ సార్ మన క్లాస్ అయిపోలేదు, ఆగండి.
సరే సరే
కొంతమంది ఎగ్జిట్ అయితే వస్తుర్రు, అలా క్లాస్ అయిపోలే ఇంకా.
సరే సరే ఓకే ఓకే. People, good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So your class is over?
Yes, sir.
Yes, sir.
Okay. Now let us move forward.
కిరణ్ సార్ కిరణ్ సార్ మీ మ్యూట్ లో ఉన్నారు. కిరణ్ సార్ మ్యూట్ లో ఉన్నారు.
మ్యూట్ లో ఉన్నానా? అన్మ్యూట్ చేసిన.
ఓకే
People, you can see the screen.
Yes, sir.
Okay. So yesterday can someone tell where did we stop last class? Where did we stop last class? What was the last concept we discussed?
Converting binary into decimal. Decimal numbers into a binary number.
Okay. See here, yesterday's class we discussed about converting decimal to binary. Can you see the screen?
Yes, sir.
Someone is muting me off. They're muting me. I don't know who is that. Okay. So yesterday's class we discussed about how to convert decimal to binary. Okay. And also how to convert binary to decimal. Okay. With and without decimals we have seen. Okay. How to convert a decimal number to binary and binary number to decimal, both. Okay. With respect to what do you call if the number is an integer part or if the number is a floating part. Okay. That means with and without decimals. Okay. Both conversions we have seen. Now tell me, what is the logic here to convert decimal to binary? Tell me what is the logic? What do you do here? Decimal to binary. What do you do?
Divide with 2.
Divide by 2. Okay. Divide by 2. Dividing by 2. Okay. That is what you do. Right. Right. Now, and how to convert binary to decimal? Tell me, what is the logic? Binary to decimal. What is the logic? What do you do here? Multiply. Okay. Multiply to the powers of 2. Multiply to the powers of 2. Multiply to powers of 2. Okay, powers of 2 and take the sum. Okay, and take the sum. And take their sum. And take their sum. Okay, so this is the logic we have seen yesterday. Yes or no? Right? Say yes or no? This is the logic we have seen. Yes or no?
Yes, sir.
Yes, sir.
Then after this, now tell me how to convert decimal to octal. Tell me, based on this logic, how do you convert decimal to octal? Decimal to octal. Decimal to octal. How do you convert? Same logic. What you should do here?
Divide with 8.
Divide by 8. Very good. Okay, divide by 8. Okay, and octal to decimal. What is the same logic? Same logic. Okay, what is it? Multiply 8 powers. Okay,
Sir, unmute.
someone is muting me off. Okay, constantly. Okay, and then take the sum. Right. Then after this, tell me decimal to hexa. Decimal to hexa. Tell me what is the logic? Decimal to hexadecimal. Same logic. You have to divide by what? 16. Okay, 16. Same logic is applicable here. Okay, and then hexadecimal to decimal. Hexadecimal to decimal. Okay, again it is the same logic. What is the logic? Multiply to the powers of 16 and take their sum. Multiply to the powers of 16 and take their sum. Okay, so far we have seen how many conversions? 1, 2, 3, 4, 5 and 6 conversions. Okay, people, you got it?
Yes, sir.
Okay, got it, right? Now, next what we have to see is how to convert just a minute. How to convert a binary number to an octal number. Okay, next we have to see how to convert a binary number to an octal number. So these are the things that you got to see now. How to convert a binary number. Okay, binary number to octal. Okay, the easiest way to remember. Okay, the easiest way to remember is, see here. Okay, here I am taking all decimal numbers. Okay, see here, right? See decimal. Okay, decimal to binary. Okay, and then the reverse, Next is decimal to octal, and then the reverse. Next is decimal to hexadecimal, and then the reverse. Okay, people got it? Next, okay, we have to see binary to octal. Okay, binary to octal and binary to hexadecimal. Okay, binary to octal and binary to hexadecimal. Binary to octal and binary to hexadecimal. These are the two things that you have to see. Okay, so let us go with the next concept. Some of these questions, okay, some of these questions will come for your, okay, quiz competition. People, are you listening? Yes or no?
Yes, sir. Yes, sir.
Okay, be a bit louder.
Yes, sir.
We are having a
Yes,
quiz.
sir.
We are having a quiz on what do you call? Basic computer skills. Yes or no? It is on 15th. All of you should know the schedule. Yes or no? 15th you are
Yes,
having.
sir.
15th you are having business basic computer skills, right? So a few questions from whatever I am teaching will be there. So it will be easy for you, right? Next, what we are going to do is we are going to convert. What is that? Conversion from binary to octal. How do you convert binary to octal? Okay, so the next conversion is binary to octal. Binary to octal. Binary to octal. Okay, so what we are going to do here is, now tell me, two students are there. Okay, two students are there. Now, how many bits do I need to number these two students? Okay, two students are there. Okay, two students are there. Okay, for example, student A is there. Okay, student B is there. Okay, then how many bits do I need to give them numbers? Tell me, how many bits do I need to give them numbers? Bit means what? Bit means 0 and 1. Yes or no? Bit means a 0 or a 1. Bit means a 0 or a 1. Okay. Now tell me, two students are there, right? So I want to, what do you call? Give them numbers. So tell me, in how many ways I can give numbers to these two students using zeros and ones? Tell me. Using zeros and ones.
Two ways.
Both of them 0.
No. Both of them 0. No, you can't give both of them 0 because no two students can have the same number. Yes or no?
0 1 1 0.
In two ways.
Ways.
In two ways only. In two ways only. Because if you are giving both zeros or both ones, okay, their roll number will be the same. Okay, it's something like roll number, giving roll number to students. Okay, just for identification. For identification, if you are giving both 0, then you cannot identify who is A and who is B. So I can give A as 0 and B as 1. Okay, people, right? Or I can give A as 1 and B as 0. So there are how many ways now?
2 factors.
There is only one way, I should say. There is only one way, because if I am giving A as 0, then obviously B has to be given 1. Okay. Then if I am giving 1, obviously B has to be given 0. Okay. Now assume the same thing. Assume the same thing. There are four students now. Okay. A, B, C, D. Okay. A, B, C, D are there. A, B, C, D. 4 students are there. Now I have to give numbers to them. Now how many bits do I need? 4 students are there. How many bits do I need? Tell me, to give their numbers.
3.
Is 1 bit sufficient or 2 bits sufficient? Sorry, how?
4.
I don't need 3. Okay, 2 bits are sufficient for me to give them numbers. Okay, 2 bits are sufficient for me to give these 4 students numbers. So what I'll do? What are the 2-bit combinations? 0 0 I'll tell. Okay, 0 0. Write it here so that you will not get confused. So if I'm taking 2 bits one at a time, then I can take various combinations like 0 0. Okay, 1 0. Okay, then what is this? 0 1, and last I can take 1 1. Okay, so what I'll do? 0 0, I'll give it to A. Okay, 1 0, I'll give it to B. For C, I'll give 0 1. For D, I'll give 1 1. Okay, is this enough now? Can I differentiate all these 4 students? Yes or no? Yes or no? So if I am given 2 bits, if I'm given 2 bits, then how many students I can give roll numbers? 4 students. 4 students I can give roll numbers if I'm given 2 bits. Okay, if I'm given 2 bits, I can give 4 students roll numbers. That means how many numbers I can represent? Tell me. Using 2 bits, I can represent 4 numbers. Okay, so instead of students, okay, now instead of students, you take this ABCD as numbers. Instead of students, you take this ABCD as numbers. Okay, that means first number can be given this code, second number can be given this code, third number can be given this code, fourth number can be given this code. Okay, now assume there are 8 numbers, okay, or 8 students. 8 numbers or 8 students. Now tell me, how many bits do I need? How many bits do I need? If there are 8 students or 8 numbers, I want to represent them uniquely, so that there should not be any clash. Okay, now you can see here, using these zeros and ones. Okay, using these zeros and ones, only 0 and 1, how many numbers I can represent? 2 numbers. I can represent 2 numbers. Okay, now using a 2-bit combinations. Okay, how many numbers I can represent? 4 numbers I can represent. Now I want to represent 8 numbers. Okay, 8 numbers I want to represent. Okay, 8 numbers. So how many bits do I need? Tell me. 8 numbers I want to represent. How many bits do I need? Is 2 bits sufficient? Using 2 bits, I can represent only 4 numbers. Only 4 combinations are there, so 4 numbers only I can represent. Okay, people, are you getting me? Now I want to represent 8 numbers. So how many bits do I need?
4.
4. Oi, 3 is sufficient. Okay, 3 is sufficient. Yes or no? See, for example, like this, 3 bits are sufficient. 0, 0, 0. Take all the various combinations. Okay, then take, I'll do like this: 1, 2, 3, okay, 4, 5, 6, 7, 8. Okay, 8. Then what I'll do? This I'll tell 0, 0. This I'll tell 1, 1. Okay, this again I'll tell 0, 0. Okay, and this again I'll tell 1, 1. Okay, again this I'll call 0, 1. Again I'll call 0, 1. I'll tell you how to construct this easier method. I'll tell. Okay, 0, 1. Okay, 0, 1. What is this? Somewhere I went wrong. 0, 1, 0, 1, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. Okay. 0, 1, 0, 1, 0, 1, and that's it. Okay. This is 0. This is 0 and 1. Right? 0 and 1. Now tell me. These are all the various possible combinations. Okay. How many combinations I got? Tell me. How many combinations I got? People, how many combinations I got? 8 combinations. Yes or no? Yes or no? Yes. 8 combinations. Yes. And how many bits I have taken? 2 or 3?
3.
3 bits. 3 bits. Using 3 bits, I got 8 combinations. That means 8 numbers I can represent. I can represent 8 numbers. Or if I am taking 8 people, okay, 8 students, to these 8 students, I can give numbers. Okay, it's like that. First student, I'll give this number. Second student, I'll give this number. Third student, I'll give this number. Fourth student, I'll give this number. It's like that. Like that, 8 students, I can give 8 different numbers. Okay. So instead of numbers, you take it as what you call digits only. Digits. That means 0, 0, 0 can represent one number. 0, 0, 1 can represent one number. 0, 1, 0 can represent one number. 0, 1, 1 can represent one number. Like that. Okay. That means 8 numbers. Okay. So okay, people, right? Now, let us get to the topic. Why all these things are important is you should understand the concept behind this. Now, if I want to convert binary to octal, okay, if I want to convert binary to octal, I have to construct something called as a 3-bit table or an octal table. Okay, 3-bit table or an octal table I have to construct. Okay, so how do I construct this 3-bit table or the octal table? Okay, now whatever you are seeing here, okay, is nothing but a 3-bit table or an octal table. Okay, now tell me, I'll tell you how to construct the octal table. Please listen carefully. Okay, you have to construct the octal table. Okay, in order to convert binary to octal, You have to construct what? You have to construct octal table. You have to construct octal table. TABL. Okay, octal table. Octal table will consist of how many bits? Tell me. Octal table. How many bits combinations I should take? Octal. Octal means 8. 8. 8 means 3 bits combinations you should take. 3-bit combination you should take. Okay. So in octal, tell me what are all the values? What values are allowed in octal? Tell me. 0 to octal. What values are allowed? 0 to
7.
7 only. 7 only. Very good. Okay. 0 to 7. 0, 1, 2. Okay. 3, 4, 5. Okay. 6 and 7. 0 to 7 only. 8 is not there. Okay. Octal. Totally 8. 0 to 7. So what I'll do is, see here now. Here I'm drawing a line. Okay, I'm drawing a line. Now I have to generate the octal values. Okay, 3-bit combinations. So what I'll do is, so totally 8 values, no? Totally 8 values. So what I'll do, this is the way that you have to construct the octal table. Okay, so first 4 I'll take zeros. Since 8 values are there, first 4 I'm taking what? Zeros. Okay, next 4 I'm taking ones. Next 4 I'm taking ones. Okay, next 4 I'm taking ones. Okay, people, are you getting me? Octal means 8. Okay, 8 by 2 is how much? Tell me. 8 by 2.
4.
4. 4. Okay,
4.
Since you're taking 4, since you're getting 4, first 4 I'm taking 0. Next 4 I'm taking 1. People, are you getting me? First 4 I'm taking zeros. Next 4 I'm taking 1. Now tell me, 4 by 2, how much?
2.
2. Okay, 4 by 2 is 2. So what I'll do here is, now I'll take this first 4. Okay, this first 4. This first 4 again I'll divide into zeros and ones. Okay, this first 4 again I will divide into zeros and ones. Tell me, if I'm dividing into zeros and ones, what I'll get here? I'll get first 2 zeros. Okay, and then 2 ones. 2 zeros and 2 ones. Okay, now next 4 are ones. Tell me what I should do? Again divide it by 2. So this will be first 2 I'll get zeros. Next 2 I'll get ones. Next 2 I'll get ones. Okay, it's like this. Okay, now again divided by 2. Again divided by 2. Tell me, if you are again dividing by 2. Okay, 2 by 2. 2 by 2 is how much? Tell me.
1.
1. So what I'll do? I'll take combinations of zeros and ones. These 2 bits I'll take. Okay, this first I have taken this. Okay, then I have divided into 2 zeros and 2 ones. Okay, next I have taken this. I'm taking this. Sorry, not this. This one. These 2. First 2, and then again I have to divide it into zeros and ones. Okay, so this will be 0. This will be 1. Okay, this will be 0. This will be 1. Okay, this will be 0. Okay, this will be 1. This will be 0, and this will be 1. Okay, so this is what is called as your octal table. This is what is called as your octal table. Okay, see now, right? I'm drawing a line so that you people, okay, people who are having vision problems, they don't get confused. Okay, people with vision problems, right? So it's like this, right? So this is how you should construct an octal table. Likewise, you should also construct a hexadecimal table. Hexadecimal table. Okay, so what is hexadecimal table? Tell me. When we are dealing with hexadecimal, okay, we'll get back to it. But now tell me, did you understand this? So again, I'm explaining. Octal table will consist of values from 0 to 7. Yes or no? So this is 0, 1, 2, 3, 4, 5, 6, and 7. Okay. So initially, what I'm doing is, since totally 8 values are there, 8 values are there. So what I did is, see here now, observe carefully. What I did is, I have taken first 4 as zeros. Okay, people, first 4 I have taken as zeros. Okay, next 4, what did I do? Next 4 I have taken as ones. Next 4 I have taken as ones, zeros and ones. Okay, next after that, what did I do? Tell me. What did I do? I have taken the first 4, and then again I have divided it by 2 bits. Okay, where first 2 are zeros. Okay, next 2 are ones. Next 2 are ones. Okay, likewise here also, first 2 are zeros. Okay, and the next 2 are ones. Next 2 are ones. Okay, then I have taken this again. Okay, then I have taken this again, and then 0, 0 I have divided it into 0 and 1. Again 1, 0 I have divided into 0 and 1. Okay, 0, 0, 0 and 1, 1, 1 and is 0 and 1. Okay, People, did you understand?
Yes, sir.
Okay. Right. So this is what is an octal table. Octal table. Now, can you construct a hexadecimal table? Tell me, based on this. Hexadecimal means how many? What do you call bit combinations you should take? Hexadecimal. How many bit combinations you need? For octal, you need 3. For octal, you need 3. Okay, for octal, you need 3. Hexadecimal means 4 bit combinations. 4 bit combinations you should take. Okay, but we'll go into hexadecimal later after we finish off octal. Right? After we finish off octal, we'll go into hexadecimal. Now, I'll give you a problem. Convert this binary into octal. Okay, convert this given binary into octal. Take this problem. Convert this given binary into octal. The binary is 1 0 1 1 0 1 1. Okay, convert this binary, okay, into octal. Octal means to the base what? To the base 8. Convert it to the base 8. To the base 8. Okay, people, how are you going to do this? Okay, how are you going to do this? Right? Tell me, any logic is there for doing this? Any logic is there for doing this? Okay, listen carefully. Listen carefully. So what I'll do is, see here, in order to get octal, how many bit combinations we need? Just now, so many times I'm repeating. How many bit combinations we need?
3.
3 bit combinations. So you move from left to right like this. Okay, you move from right to left. Okay, move from right to left. Okay, so whenever I'm moving from right to left, okay, these are my first 3. These are my first 3. Yes or no? Okay, right to left. Okay, these are my first 3. Right? Again move. Next 3 you take. Next 3 you take. Okay, this one. Okay, this one. Now tell me 0 1 1. What is the equivalent in octal table? 0 1 1. What is the equivalent in octal table?
3.
0 1 1. Okay, 3. Okay, exactly. Very good. Okay, so you see here, where is 0 1 1? Okay, where is 0 1 1? Okay, this 0 1 1. Okay, so where is this 0 1 1? 0 1 1 is here. And what is the octal value? Octal value is 3. Octal value is 3. So you write 3 here. You write 3 here. Okay, now tell me the next octal value. Next octal value.
6.
0 1 1. Where is this 0 1 1? Here. Sorry, again 0 1 1 only, no? Okay. 6 etra vachindi. People, how you got 6? This one. Okay, you have taken first 3. First 3, 0 1 1. This is 0 1 1. First 3 bits. See here, where is that combination? 0 1 1. 0 1 1 is here. So I have written 3. Okay, 3. It is corresponding with 3. So here also 0 1 1 only. Yes or no? 0 1 1. So where is this 0 1 1? 0 1 1 is again here 3 only. Okay, 3 only again. Okay, 3. Okay. Now tell me how many digits are left here?
1.
1. Okay, only 1 digit is left. So using 1, can you construct octal? Using 1 digit, can you construct octal? Using 1 bit?
Yes.
You cannot construct octal. You cannot construct octal using 1 bit. So what I'll do is, here I'll add 2 more zeros. Okay, in the beginning, I'll add 2 more zeros. Okay, easy. Any problem if I add 2 more zeros here at the beginning?
No, sir.
No problem. No problem. You can add as many number as zeros in the beginning. So no problem. Okay. So now I've got 3. Now I've got 3 bits. Okay. Now tell me, this is corresponding with what? 0 0 1.
1.
0 0 1 is corresponding with 1. Okay. So this is your octal equivalent of your binary number. Okay. This is the octal equivalent of your binary number. This is the octal equivalent of your binary number. Okay, people, you got it. Okay.
Sir, why only we should take 3 digits?
3 digits only you should take, because using 3 bits you can represent 8 numbers. Yes or no? 2 power 3. Okay, 2 power 3 means what? Tell me. 2 power 3 is coming to what?
8.
2 2s are 4, 4 2s are 8. In octal, how many numbers are there totally? In octal, how many total digits are there? 8 only. Okay, 0 to 7, totally 8, no? That is why I have to take 3 3-bit combinations. 3 3-bit combination. Now you can see here, using this 0 0 0, okay, this first row. Okay, first row is representing what? 0. Okay, second row 0 0 1 is representing what? 1. Okay, third row 0 1 0 is representing what? 2 in octal. Fourth row 0 1 1 is representing 3 in octal. Fifth row 1 0 0 is representing 4 in octal. Okay, sixth row 1 0 1 is representing 5 in octal. Okay, likewise 1 1 0 is representing 6 in octal. 1 1 1 is representing 7 in octal. Okay, so totally I have to take 3-bit combinations. That is why I need 3 bits. I need 3 bits. People got it? I'll give you a minute. Just go through this. Okay, if you have any doubts, you ask me. Okay, just go through it carefully, because if you understand this, then you will understand everything. Okay. Okay, constructing this table is important. Constructing this table is important. Okay, constructing this table is important, right? People, you understood? Shall we move on? If you want, you take a screenshot of this. If you want, you take a screenshot of this. Okay, and then let us move on. Now, this is number without decimals. This is number without decimals. Okay, now let me give you a number with the decimals. With the decimals. Okay, 1 1 0. Okay, 0 1 0 1. Okay, 1 2 3 4 5 6, then 7 8. Okay, point, then I'll tell point, I'll tell 1 0 1 0 1 0, something like this, 0 1 0. Okay, now this is a number with decimals. This is a number with decimals. Okay, this is in binary. Okay, now construct its equivalent octal. Construct its equivalent octal. Construct its equivalent octal. People, tell me how to construct its equivalent octal. At least the integer part you should be in a position to construct. Tell me what is the value for integer part. Take 3 3 bits. Okay, take 3 3-bit combinations. 1 2 3, 1 2 3, and then 1 2 3. Now tell me the values. What is 1 0 0 here?
24.
1 0 0. 1 0 0 is
4.
4. Okay, 1 0 0 is 4. Okay, okay. Next 3-bit combinations. 0 1 0.
2.
2 2. Okay, next first combination 1 1 0.
6.
6. Okay, 6. Very good. Okay, now decimal part. Point. Okay, point. Now tell me. So when you are coming to the decimal part, okay, what you got to do is you got to do the reverse. Okay, here if it is an integer part, you move from right to left. Okay, you move from right to left in integer part. Okay, so when you are coming to the decimal part, you have to move from left to right. Okay, left to right like this. So these are the first 3 and these are the next 3. Okay, first 3 and next 3. Now tell me the values. Move from left to right. 1 0 1.
5, sir.
5.
1 0 1 is 5. Okay, 5. Now 0 1 0. Next
2.
0 is 2. 0 1 0 is 2. Okay, so this is the equivalent, what do you call, octal value for this decimal, I mean for this binary number which is having decimals. Okay, people got it? You take a screenshot of this. Okay, you'll understand it very clearly. Everything is there. Everything is there in this diagram. Everything is there in this diagram. Okay, how you are constructing the octal table and how you are selecting the 3 bits at a time, right? And all these things, everything is there. Okay, people got it?
Yes, sir.
Okay, so now see here, thing you have to remember here is, if you are falling short of bits on the left side, if you are falling short of bits on the left side, okay, then you can add extra zeros here. Okay, then you can add, see here, like this. In this example, I've added this extra zeros. Yes or no? Okay, because you are falling short of 3 bits here. Now, what if you fall short of bits here on the right side? On the right side, here, if you are falling short of bits, then what you should do? Tell me. For example, here, if the value is 101, okay, if it would have been like this, 101, 010, okay, then followed by 1, okay. Now you're taking 3 bit combinations. So this is the first 3. After decimal, I'm taking, okay. And this is the next 3. And here, sorry, this is the next 3, right up to here. And only 1 bit is there here. So what about the remaining 2 bits? What I should do? This one, after 1. After 1, what I should do? I hope you understood, right? These are the first 3 bits, right? These are the second 3 bits. Okay, but only 1 is there. I need 3 bits. Okay, what I should do here? I'm talking after. I'm talking about after decimal. After decimal. Okay, so take zeros here. Okay, if I add any number of zeros, is it going to matter? No. Okay, it is not going to affect in any way. Okay, you can add any number of zeros here. Okay, if you are falling short of bits, you add zeros here. Any number of zeros you can add. Okay, people, are you getting me?
Yes, sir.
Likewise, before, if you are adding zeros before, it doesn't matter. Okay, likewise in the integer part. In the fractional part, if you are adding zeros after, then also it doesn't going to matter. Okay, after the number, after the digits, right? So now, based on this, can you construct me hexadecimal table? Tell me. Hexadecimal table. Instead of octal table, I want hexadecimal table. Okay, tell me. If you know how to construct the hexadecimal table, then we are almost done. Okay, we are almost done. Tell me. Now, in order to hexadecimal values, what are the values? Tell me. Totally in hexadecimal. Hexadecimal values. So, next conversion is what? Binary to hexadecimal. Binary to hexadecimal. Okay. So, it is binary to hexadecimal. Looking at this, you can construct binary to hexadecimal. Binary to hexadecimal. Okay. Now tell me, hexadecimal I want to construct. So I have to construct what table? I have to construct hexadecimal table. I have to construct hexadecimal table. Okay. Now you should help me in constructing this hexadecimal table. Hexadecimal table, you should help me to construct. Okay. People, tell me now, hexadecimal. So tell me, what are all the values in hexadecimal? Tell me what values are there? People, you are there? Tell me what values are there in hexadecimal?
0 to F, sir.
0 to F. Okay, 0 to F. Yes or no? Right? Yes. Okay, 0 to F are there. So tell me, first write down all 0 to F. Okay, 0 to F. 0 to F you write down. So 0, then 1, then 2, then 3. Okay, totally 16 I want. Okay, 4, 5. Okay, then 6, then 7, then 8, 9. What is 10? What is 10? Huh? 10 is what?
A.
A. Okay, very good. Okay, A. 11 is what? B. 12 is C. 13 is D. 14 is E. And 15 is F. Okay, this is E and 15 is F. Okay. Now tell me. 16 by 2 is how much? Total 16 values. So 16 by 2 is how much?
8.
8. Okay, 8. So first is this. So this first 8 digits, okay, you take zeros. You take what? zeros. Okay, so 0, 0, 0. Okay, 0, 4 zeros, 5, 6, 7, 8. Okay, so up to here I have taken zeros. Okay, now what next 8? Next 8 what I should take?
One.
Ones.
One.
Okay. Ones. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now what you should do? You take this half. You take this first half. Okay. This first half again you should divide into zeros and ones. This first half is,
एल्बम भी रखे दो ऊपर.
okay. This first half you should take into zeros and ones. Okay. Tell me now. This first half I should take into zeros and ones. Tell me.
8/2, sir.
8/2. Okay. So
4.
first 4 will be what? Zeros.
Zeros.
First 4 will be zeros. 0, 0, 0, 0. Next 4 will be ones. 1, 1, 1, 1. Okay. Next, after this again, first 4 will be zeros. Okay. And next 4 will be what? Ones. 1, 1, 1, 1. Okay. Now next what I should do? Tell me. 4/2. 4/2 is 2. Okay. So here, first 2 will be zeros. Next 2 will be ones. Okay, people, right? First 2 will be zeros. Next 2 will be ones. First 2 will be zeros. Next 2 will be ones. Okay. First 2 will be zeros. Next 2 will be ones. Okay. Last one. What I should do? Last one is 2/2 is 2/2 is 1. So simply I'll write 0, 1. Okay. 0, 1. Okay. 0, 1. Okay. 0, 1. 0, 1. Okay. 0, 1. 0, 1. 0, 1. Okay. And then finally 0 and 1. People. Okay. Simple. Very easy. Okay. You don't have to worry about these things, right? You should know how to construct this table. See here. Here. So what I did is, so initially I have taken this 8. Okay. 8 means up to 7. 0 to 7 totally 8. Okay. I have divided into zeros and ones. See here. All this I have taken zeros. Okay. All this I have taken as zeros. Okay. And all this I have taken as what? Ones. All this I have taken as ones from here to here. Okay. Next I have divided this into this one. Okay. This 4, 4. Okay. 4, 4 means this one. It's like this. Okay. Then what did I do? I have divided it into zeros and ones. I have divided into zeros and ones. Okay. Like this. Zeros. Okay. And then ones. Okay. Then again zeros and then ones. Okay. Okay. Then what did I do? I have taken this, what do you call? This thing, divided it into 2 2s. Okay, 2 2, something like this, right? 2 2 bits. So like this I have divided. Okay. And then what did I do? I have divided it into again 2 2 bits. Okay. So first 2 zeros, next 2 ones. Okay. First 2 zeros, next 2 ones. Okay. First 2 zeros, next 2 ones. Like this. Okay. It's very easy, right? So this is how, and the last one I have simply taken 1 1 bit, 0 1 0 1 0 1 0 1 like this. Okay. People got it. It's like this. Okay. Take a snapshot of this. Take a screenshot of this. This is how you construct. This is how you construct your hexadecimal table and octal table. Okay. Hexadecimal table and octal table. So why am I taking 4 bits only? Can someone tell why I'm taking 4 bits only? People, why I'm taking 4 bits? Because how many values I want? Why I am taking 4 bits? Because how many values I want, tell me? Hexadecimal total how many values?
16.
Hexadecimal total 16. Total 16 values I want. So I have to take how many bit combinations? 4 bit combinations. Because 2 power 4 will give me how much? 2 power 4 will give me how much? 16. 2 power 4 will give me 16. Okay, 16. What are the 16? Tell me. The 16 are this one. Okay, 0, 1, 2, okay, 3, and so on up to, and so on up to what? And so on up to F, and so on up to F. Totally 16. That is why I should take 4-bit combinations. 4-bit combinations. Here I should take 3-bit combinations in octal. Why 3-bit combinations? Because I want values from 0 to 7. 0 to 7. Okay, people? Got it? I hope you have understood it, right? So what you got to do is, okay, take down a paper, okay, take down a sheet of paper, okay, take your own problems, okay, frame your own problems, and then try to do these conversions, okay. So next class we'll see how to convert this, okay, binary to hexadecimal, and in between conversions like octal to hexa to octal and all those things. With the by next class we'll be completing this number systems, okay. By next class we'll be completing this number systems, right? So few questions you'll get from this, what do you call, for any competitive exam you take, okay, definitely I can expect around 2 questions from this, what do you call, number systems. And binary arithmetic also is a concept which is important, that I'll see if time is there, I'll discuss about binary arithmetic, okay. Okay, people, I think you are writing this, what do you call, attempting the quiz, yes or no? What quiz is today?
Economics.
Economics, okay, right. So I'm winding up the session. Do send the attendance, right? Send me the attendance, please.
Okay, sir.
Thank you, sir.
Thank you, sir.
Right, right.
క్లాస్ అయిపోయిందా? క్లాస్ అయిపోయిందా అమ్మా?
సరే అయిపోయింది.